Welcome to part 1 of our Chapter 4 review video. So for number 1, we've got an angle measure written in degrees, minutes, and seconds. So what you need to know is that 1 minute is equal to 1/60th of a degree. And then 1 second is 1/60th of a minute. So using that, we can rewrite this angle measure as 57 plus 29 over 60 plus 38 over 3,600. This is a 60th of a 60th is 1/3,600th. So in our calculator, 57 plus, let's try that again, 57 plus 29 divided by 60 plus 38 divided by 3,600. And it asks us to round to the nearest hundredth. That's 2 decimals. So we get 57.49 degrees. Okay, number 2, convert from degrees to radians. Use the value of pi found on a calculator and round answers to 4 decimal places as needed. Well, notice that these give us exact answers, so that's really what the problem wants. We're given an angle measure, and we want to convert it to radians. Well, what do we need to multiply by? Well, we multiply by 1 in the form of pi radians over 180 degrees. Now, to leave pi in the answer, you are not going to type pi in the calculator. You just do 510 divided by 180. Now, this is going to give you a decimal. Notice that we don't see any decimals here. So to convert it to a fraction, we push the math key and then enter twice. And we get 17/6, which means this is 17 pi over 6. Number 3, we're converting radians to degrees. So instead of multiplying by pi radians over 180 degrees, we're going to multiply by 180 degrees over pi. Pi's cancel out. 5 times 180 divided by 6, and we get 150. So once again, the answer is B. Number 4, use the arc length formula. Well, here is the arc length formula. S equals R times theta, where R is the radius, and theta is the measure in radians, and S is arc length. Number 4 is giving us R and theta. 4 inches times 11 gives us 44 inches. And our answer is D. Now, in number 5, we're still dealing with arc length. We're still going to use the S equals R theta formula, but notice that our degree measure is not in radians. This formula only works if the degree measure, or if the measure of the angle, I should say, is in radians. So we need to make a conversion first. So 36 degrees times pi over 180 degrees. And we see that's 1/5 pi. So this is equal to 1/5 pi, or pi over 5. So we're given S, 12. We're looking for R, and we know theta is pi over 5. So we solve for R. I'm going to multiply both sides by the reciprocal of pi over 5, which is 5 over pi. So R is equal to 5 times 12, which is 60, divided by pi. And our answer is D. Number 6. The radius of the Earth is approximately 3,960 miles. What is the linear speed on a point on the equator in miles per hour? So we know that the Earth revolves every 24 hours. So I know it makes one revolution every 24 hours. So how far does a point on the equator travel in one revolution? Well, one revolution is simply the circumference of the circle. And circumference is 2 times pi times radius. So the circumference is 7,920 pi miles. So over here, we know that one revolution is 7,920 pi miles. Revolutions cancel out, giving us miles per hour, which was the unit specified in the problem. Then we get about 1,037 miles per hour. And we see that that is C. Okay, number 7. Find the exact values of the indicated trigonometric functions. So we're looking for secant of angle A and cosecant of angle A. Well, we know that secant is the reciprocal of cosine. So it's hypotenuse over adjacent. Cosecant is the reciprocal of sine, so it's going to be hypotenuse over opposite. So for secant A, the hypotenuse is 51. Recall the hypotenuse is always the longest side of a right triangle. It's also the angle opposite of the right angle. And then the adjacent to angle A, remember adjacent means next to, is 24. Looking at the answers, you do not see 51 over 24. You can reduce it either with your mind or the calculator. And we see we get 17/8. Cosecant is hypotenuse over opposite. The opposite side of A is 45. And you can do that in the calculator if you want, but I know 3 goes evenly into both these numbers. 51 divided by 3 is 17. 45 divided by 3 is 15. Looking at our responses, we see that C gives us the correct answer. Okay, number 8. We have sine, and we're looking for cotangent. What I like to do is draw a triangle, a right triangle. I'm going to label one of the acute angles as theta, where the measure is theta, and I'm going to use this ratio to make two sides of this triangle. Now we know that sine is opposite over hypotenuse. So the opposite side would be over here. That could be 1. The hypotenuse, I will make that 2. Now, cotangent is the adjacent over the opposite. We don't have the adjacent side, so we'll use the Pythagorean theorem to find that side length. A squared plus B squared equals C squared. So we get 1 plus x squared equals 4. X squared equals 3. And because we don't need to worry about negative roots in this problem, that length is radical 3. So then the cotangent of theta, which is adjacent over opposite, would be radical 3 over 1. And we see that answer is A. Okay, number 9, give the exact value of cotangent of pi over 3. So I'm going to recommend that you get out your unit circle. Go ahead and pause the video if you need a moment. And once you've found it, I want you to find the x and y coordinates for pi over 3. What's the x and y coordinates for pi over 3? We get 1/2 from radical 3 over 2. Cotangent of any angle is the x over y. So the x coordinate is 1/2. The y coordinate is radical 3 over 2. So to simplify, I'm first going to divide, and I'm going to change it to multiplication. This is the same thing as 1/2 times 2 over radical 3. Those cancel out, giving me 1 over radical 3. I don't see 1 over radical 3, so I need to rationalize this answer. And I can do that by multiplying by 1 in the form of radical 3 over radical 3. 1 times radical 3 is radical 3, and radical 3 times 3 is 3. Now we see that the answer is B. We'll go ahead and pick up with problem number 10 on part 2 of the video.